All right. Thank you so much for joining over our webinar series. And for those who just joined this webinar series, we are actually in our second webinar topic. And we have a webinar series in the future will be shared to you. Okay, so I am Perez Bisnar, a registered electrical engineer and a product marketing specialist for low voltage components and solutions. By the way, guys, we encourage you to ask questions during the presentation through the Q&A chat box, and our team will try to answer those questions that you have in the chat box. And if not, then we will discuss this after the presentation. Okay. All right. So going on in our agenda is that first we are going to discuss about the sensitive component sag immunity standard. So when we say about this standard, this is about the immunity of a certain sensitive components that is being used, whether it's in the semicon industry, commercial industry, or F&B industry. Also, we will also discuss the types of power quality problems and their solution, and when the solution is needed, and what kind of solution that we need to use in the type of power quality issue. And lastly, we will have an ABB overview of the power protection, but this will be focusing on active voltage conditioner and industrial UPS. Okay. So as for starters, I have some questions. So what are the types of power quality issues that you know or probably you have experienced? So you can put your answer on the white spaces using the annotation box that is in your left that's in the left side of your screen. Okay. All right, good input. Harmonics. Okay. Transients. All right. So you can also use those text symbol. All right, SAG. All right. Thank you. So SAGs are actually one of the common problem. Okay, noise. Yes, or we can consider this as a flicker. Okay. Yes, flicker. Voltage dip. Yes. Voltage spike. Yes. Or voltage surge. Yes. Outage. So yes. So those are the main power quality issues that we are actually experiencing here. So as an introduction for the active voltage conditioner, okay, so for this active voltage conditioner, the issue with our power quality is that even with the advanced protection or grid that we have, long interruptions and blackouts are very rare. So typically, these blackouts and interruption are, as we know, for well, at least for the Luzon grid. So we did not experience any blackouts or interruption for the last 3 years. If there is, probably it's just a short interruption, and then we will have our power back. So this is actually one of the power quality issues that we are going to address. And also, with the modern society, when we talk about the processes in terms of semicon, FNB, even commercial buildings in terms of air conditioning unit, okay? So these processes are going to be automated, okay? So when you have automated system, it means that you are also using sensitive component, okay? But the problem here is that the facilities cannot have any advance warning that this voltage sag outage or any power quality problem that will occur in that specific structure does not have any warning or it will be absorbed by the structure itself. Okay, so actually the basic or the most common power quality that we have is the voltage sag. So 92% of all power quality events are voltage sag. So why? Imagine if we have, as we know, okay, so we have the power plant and we have the grid. So the power plant to the load, we actually have more than 100 kilometers of grid lines. Okay, so these 100 kilometers of grid lines can be disrupted by weather condition, urban construction, network failure, or even natural effects like trees that are so tall that we're able to get or reach the high tension wires that we have. Okay, so these events create power quality sags or power quality issues. Okay, just to give you an idea, the typical annual power quality events here in the Philippines. Okay, so this is a 1 year power quality monitoring. On your left side, the vertical one is the percentage of voltage or remaining voltage when there is a sag depth. Okay, while on your horizontal vector, this is the sag duration. So imagine this sag duration is actually in milliseconds. All right. So as you can see here, the dotted red lines, we actually monitor those sag voltage that are 90% below. Okay. Why? Because a normal component can actually mitigate plus or minus 5 to 10% of this voltage fluctuation as a standard component. But there are some events that are for the components that are sensitive that we were able to monitor this. Okay, so what does it mean? Okay, so it means that if you have a very sensitive component and the voltage remaining or the sag or the depth or there is a voltage sag by 10%, some of your modern components will actually trip off. Okay, so this means that if you have this kind of component that are very sensitive, this one will trip off and also reduce its lifespan. And from here, from 90%, okay, from 90% to 60%, most of the time we will hear our contactor will chatter. And up below 60%, it will reach up to 40% remaining voltage, then our contactor will trip. Okay, so also one important part is the VSD or VFD. So if we are using variable frequency drive or variable speed drive in our system, then you will be able to have, if you have experienced this voltage sag that are 75% voltage remaining, so it means that it can run, but there is no guarantee that it will run at 75% below voltage remaining. Sag immunity or some VSD drive, but not all VSD have this voltage sag immunity. Okay, so just to give us an overview, what is the sag immunity or component standard? So we actually have three standards, which is the ITIC Semi F47 for semicon and IEC 61000. This is 61000. Okay, so this standard is to provide benchmark for product manufacturers and end user. So this is the general standard wherein a certain component should run if there would be some power quality issue. Okay, let's start with ITIC. So ITIC is the Information Technology Industry Council, which is actually the only standard that covers swells. Right? So this means that if our voltage here at 100%, okay, so this is our 100% voltage, and if there will be some voltage surges, those voltage surges should only last at 0.01 cycle. Okay, so just imagine that in a 60 hertz system, okay, for a 60 hertz system, one cycle is almost 20 milliseconds. So if you will consider 0.01 second, so this is actually in microsecond, right? So this is already in microsecond. You need to correct it, or you need to lower down that surge into 100%. So the region here, okay, that says prohibited region, it means that this region, if ever the surge will fall up to this level, right, the surge will continue up to this level and there will be no correction. It means that your component will either be destroyed or will trip off. Okay, so this is for the Swell standard. For semi F47, okay, for the semicon industry, so if you can see here at the table, right, below, so if we have a sag depth of 0%, we need to correct it for a duration of one cycle. More than one cycle, it means that this component will typically shuts off. Okay, so for our visualization purposes, okay, so this is the region we're in. Can you see the green line here? Okay, so those those power quality events that is above the green line, okay, above the green line. This means that your component will actually work. There will be no problem. They will be immune. But those components that are here in this region, okay, in this region, it means that your component will actually experience trip off, or you will have probably the process of your system will shut off because this is so low that your component will not work anymore. Okay, so this area here needs solution. All right. Okay. So what you see here is that this is in cycle, not in milliseconds. Okay. So if you have 10 cycles here, it means 200 milliseconds. So this is very fast. So we are actually seeing this graph here because we were able to zoom in on the voltage sag. On the voltage sag event. Okay. So and also there is this one standard that we call IEC 61000. Okay. In this 61000, the standard is the class 2 and class 3. Okay. So we will define class 2 and class 3. So the more the lower the class, it means that it requires strenuous protection or strenuous sensitivity. Okay, so just to give you a representation of what is class 2, so it means that those items that are below in this level or in this region, okay, in this region, it means that your component will trip off. But those items that are happening above the pink line that you have here is that your component is okay to run. But imagine when we use sensitive component, we are actually using it in a very critical batching or a very critical, let's say, conveyor system. Okay, so if this one stops, it means that all the raw materials inside that conveyor system will be a waste and it will be substandard anymore. Okay, so this will cost us a lot of money, right? So for class 3, so the class 3 is a little bit, let's say, not that strenuous, but you can see here that within 200 milliseconds, it requires us, okay, to correct the voltage. We should have a voltage that is above 40%. Otherwise, this component will turn off. And here, there are 2 test points that are in one cycle. And remember, if we have 0% voltage or 0% voltage remaining, okay, we need to correct it within one cycle, otherwise this component will turn off. Right? Okay. So now that we know this component standard that we have, then I will give you an idea of what are the power quality problems and solution that we can, that in a very in an overview. Okay. So in an overview of the power quality problem and solution, first we need to identify that there is basically two major power quality problems. The first is the utility power quality problem. So it means that if there is a utility power quality problem, it means that these power quality problems are issued within, or this is generated by the utility itself. So these power quality problems are voltage sags or dip, voltage swell, voltage drop, and power failure. Okay? And the second one is that there are load side power quality problem. So for the load side power quality problem, these are the power factor and the harmonics. Okay? So for this one, we also have other power quality problem, which is single phasing and voltage unbalance. And with this power quality problem that we have, okay, so we can actually see different kinds of solutions. All right. So for the solution in the utility power quality problem, we have we solve this usually by UPS. All right. So UPS is our common solution. All right. For our common solution, and we see if we were experiencing any problem, especially for power failure, we consider UPS. And for advanced solution, we consider flywheel, diesel generators. All right. But for ABB, we have this component which we call power conditioning system. Okay, PCS 100. For ABB, this is our platform. Okay. For the load side, so we are solving this with power factor problem. We solve it with capacitor banks to increase our power factor. And for harmonics, we solve it by harmonic filter. But the problem with single phasing and voltage unbalance, this is also different. Okay, so why? Because the UPS for the single phasing and voltage unbalance usually cannot solve it right away. Okay, so this makes our PCS 100 very special. All right, so knowing all this kind of power quality issue, we have an overview of ABB solution and offering. Okay, so for ABB solution and offering, we have single phase to three phase modular system. And for our topic today, we will be focusing on this side. Okay, industrial UPSs, which we call PCS 100 UPS. Okay, this one. And you can also hear that we have, you can also see here that we have UPS for medium voltage system. Okay, and you can see that we are using the platform of PCS 120 because this PCS or the UPS system that we have for medium voltage are actually class 1 standard, can actually be used for class 1 standard solution. Okay, and for our data solution, we have STS. So we have the range of 200 to 2000 ampere. And we also have the PBU. Okay. And for our topic today, we will be focusing in voltage conditioning. Okay. So in voltage conditioning system, we have two systems, which is PCS 100 ABC 20 for voltage regulation. It means that for voltage drop, okay, for voltage drop that will happen more than 1 hour a day or could be months or year, we will be using PCS ABC 20. But for sub correction, we will be using PCS ABC 40. The 20 and 40 here means the percentage of what they can resolve. All right? And last in the portfolio of power protection is that we have this PCS 100 static frequency converters, which converts 50 to 60 or 60 to 50 hertz. All right, and the load that we can handle is that up to 2 MVA. So this is an overview of what ABB can offer you. And if you have any question on the other products, please let us know. Okay? But we are gonna focus today in voltage conditioning and for the industrial UPS. All right. So to give you an introduction or a product overview, what is the active voltage conditioner? Okay, so an active voltage conditioner is actually a combination of a rectifier and inverter, and it regulates sags and swell, but it doesn't need any battery storage. Okay, so if you are having a problem with voltage sags and dip or swell, and you don't have any problem with the power outages, then this product is pretty much fit on your requirement, because this this product does not only solve this issue, but it solve it in a very fast way. Just imagine this product as an AVR. Okay, it's an AVR, but it solves the issue in a very fast way. All right. So as a benefit of this one, as we understand in the component or sensitive or sub immunity standard, so the advantage is that it can solve those power quality issues that are very fast. Okay, so that requires a one cycle solution. All right, so in just one cycle you need to solve this issue. So this product can solve it in a very fast way, and it has a very low operation and maintenance cost, and it's very durable. Okay, so technically it removes voltage fluctuation. Okay, voltage fluctuation, regular voltage fluctuation of plus minus 10%. If it goes out on this product, this will guarantee a 100% voltage. Okay, so this is what the product does. Okay, so just to give you an idea or a single line diagram, so if we have a utility voltage here, and we have a problem of a underlying under voltage, this one will be detected by the product, and it will compensate on whatever voltage percentage that he requires to give you a premium power, or to give you a premium voltage. All right, so to give you a representation, so this is a factory wherein there is no power quality protection. So you are running your factory, and then suddenly there's a voltage sag. All of those profits are lost. Okay, but with PCS 100 product, okay, so this voltage sag is actually detected within 250 microseconds, and then it is corrected within half of a cycle, thus giving you a premium power. Okay, and also with the swell protection, if you remember the voltage sag, it adds up to the power, and now it is swell, then it will work like as a vacuum to generate a 100% power to your plant and continuous profit. Okay, the profit will go up. Right? So this is the effect of this product. So just to give you an idea how fast does it do, the event correction is actually less than 250 microseconds. And the cycle or the completion of the correction is within half of a cycle. Right? So for PCS ABC 40, it means that we can have full correction at 60% remaining voltage, and the full correction for single phase in 40% remaining voltage. Right? And if ever that we will reach, or there will be voltages that are below in this system, then we will have a partial correction if the remaining voltage is at 30%. Okay, so you can see here there is a discrepancy. Why there is a 60 when there is a 60% remaining voltage, we say full correction, and then here a partial correction when it comes to 30%. Okay, in paper, all right, we actually guarantee that up to 60% remaining voltage, we guarantee that we can give you 100% voltage correction or full correction. But lower than that, let's say between 60 and 30, these are actually the performance of the system depending on the actual load. Okay, so if you have a 1:1 load, okay, so if example if you have a true load of 1 MVA, okay, and you have this system of 1 MVA, it can guarantee you full correction at 60% remaining voltage. And it will give you a partial correction if that 1 MVA load will have a voltage sag that will remain at 30%. So let's just say that this 30% can be lifted more than 70% of the voltage. All right. So also for the partial correction for the single phase, so if there is 0% voltage remaining, so there would be a partial correction. Okay. So this product will have a continuous regulation of plus minus 10% and will give you 100% premium voltage, and also it corrects vector phase angle. All right, and also imbalance. It's not just a normal or a typical AVR kind of solution, but it also generates premium power, not just voltages. All right. So the graph here can actually show you the red line is wherein the PCS ABC 40 is output voltage correction, wherein the correction time here, the requirement for a specific standard in our sag immunity is in here. So you have ample enough time. Okay. So it means that if you have a sensitive component and you put this system in your plant, it will guarantee that this sensitive component will have a longer lifespan and also will give you a longer uptime. Okay. Just to further elaborate on what is happening or what is the effect in our voltage or three-phase system, as you can see here, in a three-phase system that we have, there is a under voltage that happened in a duration of 2.5 cycles, or let's say 3 cycles. Okay, but in the effect of PCS 100 ABC output, the correction time is actually less than half of a cycle or 1/4 of a cycle. Okay, so it's almost like nothing. The system did not, or the component did not felt it. But this scenario will be logged in the PCS 100 hardware, and then you will see that this PCS 100 is actually working because you will see what is happening from the utility and the correction that it's done. Okay, and also for the single phase here, you can see the green sine wave here. Okay, the single phase correction will only took half of a cycle. Okay, so since there is a problem in the single phase and also a phase imbalance, this is also being corrected here. Okay, this is what the product can do to you. Okay, so going back to the typical annual power quality issue that we have. Okay, and then after putting the PCS ABC 40, right? So it actually corrected almost more than 90%. Okay, 90% of the issue. And also just to let you know, guys, that this red dot that we had is actually a power quality event that we did here in the Philippines. Okay, so with this product, we were able to solve almost above 90% of those power quality issues. So this power dip here or sag that left within above 70% or a partial correction, okay, partial correction that happened for PCS ABC 40 because we can only guarantee 40% correction. Okay, so from let's say this is 12% and we were able to leave it at 75%. That is actually 60% voltage correction. But we can in paper we can guarantee only 40. Okay, but this is the actual performance of our product. All right. So just to give you an overview of our standard offering in this PCS 100 ABC 40, we have our lowest. Okay, our lowest system is a 150 kVA, and we can go up to 3.6 MVA system. So typically, what we're trying to do here is that we are solving all the power quality issue of the load side. This is not a per component solution, but as a whole system solution, right? So this one has a different approach than the UPS. Okay, so the construction of this one is in a modular power converter. So we made it modular to make the cost of ownership very simple. Why? Because if it's modular, the moment you remove one module of the inverter or rectifier, then you can actually replace it by a new one. So what does it mean? Example, if you have a 1 MVA system of a PCS 100 40, and then there is one module that became defective, so it doesn't mean that all that 1 MVA system will be turned off. No? So if you have 1 MVA system, then there would be a reduce of only 150 kVA because of its modularity. So because of this modularity, and you will have this alarm, your system is still protected by 850 kVA. Okay? So this is how reliable our product is. And the maximum operating temperature is 50 degrees centigrade. So this product does not need an air conditioning system. Okay? That you just need to protect it against dust because we only have IP20 enclosure. And if you need the IP21 enclosure, this is available. All right? So just to give you an idea, the lifespan of this product is actually 10 years. And the technology lifespan is actually at a running 25 years. So it means that if there would be a problem after sales later on, ABB can support you. All right? And all the product or all product updates that we have is backward compatible. So it means that if we have updated this product, then the new product is actually compatible to the old one. Right? So there's no need to worry. And for the features, we have a continuous protection from the most common utility problem, okay? Instant response to substance swell, and designed for commercial industrial loads such as motors, transformer, and medical equipment. Guys, this product is designed for heavy loads, okay? So if you have heavy loads, like example, a motor, if you have a motor of a 600 kVA, then you will only need to have a 600 kVA PCS 100. Unlike with the UPS, you need to multiply it by 3 or 6 in order to respond on the inrush current. But with this product, it is 1:1 basis. All right? So we have this low cost of energy because there is no energy storage, right? And then the efficiency is always more than 98% regardless of the percentage load remaining. And it has a very small footprint comparing to an ABR or a UPS itself. Okay, so for the interface and connectivity, right? So we have a built-in GDM. We call it GDM. This is a 8.4 multilingual HMI here. So in here, the GDM can actually log event, right? Event can be connected into your remote PC or into your SCADA or BMS, or can actually send you an email of all those events. Okay, so this is actually what the ABB interface for PCS ABC40, and sooner we will connect it with ABB Ability ABCS. Okay, so it means that if it's connected to your ABB Ability ABCS, you can actually monitor your system, your plant performance everywhere you are, as long as you have the internet. Okay, so as a summary, so PCS ABC 100, PCS 100 ABC 40 is a correction of 40% voltage drop. All right. So, question: what if I require a correction of a very deep sag? What would I use? All right. So, with this kind of question, the solution would be the UPSI. Right. Okay, guys, when we say UPS, this is actually the same like a dual conversion UPS, but this UPS is an industrial grade. Okay, so when we say industrial grade, it works as the same of the PCS ABC 40 or 20. All right. All those solutions, all those power quality issues that being solved by the PCS ABC 40 are being solved with this component as well. But the difference of this one to a standard dual conversion UPS is that this is a single conversion UPS, and the power conversion for this one is also 1:1. You do not need to multiply it by 3 or 6 if you have a motor load. So if you have any industrial equipment like robots or welding machines, or let's say a conveyor system that you need to protect for a power quality issue, right? And it just so happened that you are installed in a facility or an environment that has a frequent 30% remaining voltage, then this is the best solution for you. Okay, so this operating range, right? So why is it offline at plus minus 10%? Because it has a continuous regulation that it does not need to use its storage capacity. Okay, so if the system is below 90% or above 110, all right, so it will use its storage capacity to give you premium power. So how does it do? All right. So example, if you have a utility voltage here and there is a zero voltage that came from a utility for a very small amount of time, then the PCS 100 UPSI will put on a value here to solve this issue, and will give you an output voltage of a premium power and voltage. Okay. So just to give you a representation of how does it do, right? So you have a utility voltage going to the plant, and then you have a voltage sag coming in. What will happen is that the product will actually detect it, and then this fail-safe bypass or utility disconnect is so fast that it will disconnect from the utility and then supply the voltage to the factory until this power quality issue is over. Okay, so once it's over, then it will go back to a normal supply. Then that's the time that the battery or the ultra capacitors will be able to charge. Okay? So when we use the battery here, the autonomy time of the battery here is 30 seconds. Only 30 seconds. Why? Because for a 30-second battery autonomy, it can solve all of the power quality problem and also interruption if you have a very quick or a very modern ATS system. So, example, if there will be a power outage that will happen and you have a modern ATS system, so it will look like that you have a CTTS function, utility to emergency because of this system. All right. And also going back to emergency to utility, it's like also a CTTS because the PCS UPSI will supply the interruption time of transfer. Okay, and for the ultra capacitor, okay, the ultra capacitor can only have an autonomy time of 2 seconds. Right? And just to give you an idea, the battery here for UPSI can last up to 10 years. It is because as you can see here, the battery is not in frequent conversion because this is a single conversion UPS. All right. So that's why that is the reason why the battery can last up to 10 years before you replace it. Okay. All right. So what does it mean? How fast does the response time of the PCS 100 UPSI? So if there is a power fluctuation or in an event that the UPSI will be used, we will have a correction time of 1.4 milliseconds. Okay, this 1.4 milliseconds is so fast. All right, it's so fast that it's actually less than 1/8 of a cycle. And if we look at in the IEC 62 or IEC standard, all right. So this is the classification 1. This is classification 1. For the classification 1, it means that if you have a 0 voltage remaining, it means that you need to supply the voltage within this region. Okay. All right. So, but UPSI is not a class 1, but a class 2. For class 2, this is the UPSI performance. Okay. Before the class 2 standard, it is already corrected. Okay. For if you have a very sensitive product that requires this class 1 protection, okay, or class 1 solution, then the solution here is the PCS 120 medium voltage. Okay, so that is our solution for a very sensitive component. Okay, so and also just to give you an idea, the PCS response time here, see, if you look at the graph, it's less than 1/4 of a cycle that it is corrected. And then when the moment that the voltage is came back to normal, then you have this correction time. Okay, so it's so fast, it's very fast. Okay, so in the standard offering of our PCS 100 UPSI, we have up to 2.4 MVA of system. So this is for the batteries, this is 30 seconds, and if you want to have an extended time, we can extend it up to 500 seconds. Okay, and the lifespan of this one is 10 years. So typical transfer time is within 1.8 milliseconds. So this is very fast, and the efficiency, guys, is always above 98%, regardless of the percentage load. So if you have a 10% load remaining, so it will guarantee you a 98% efficiency. Okay, it is not in bypass load, but it is working all throughout and monitoring the system. Okay, so For PCS ABC 100, our value proposition is actually we give the owners more profit and save a lot of money because of their process time. Okay, so and the solution that we have is an industrial type wherein you can solve the issues if you have issues for a very big load or industrial load. We can solve these issues, okay, without an extra cost of voltage. It because the conversion is 1:1, and we have a lower cost of ownership because the system is modular and the system lifespan is more than is 10 years and above. Okay, so all right, just to clarify everything, when do you need to use the PCS and when do you need to use the UPS? All right. Okay. So you will use the UPS if you have the primary protection is for power failure, right? And the the equipment that you are protecting are digital equipment like servers and PC, and the protection does not require phase solution. And normally, UPS are used for a commercial equipment, okay? And if your application is per component protection, then it is UPS. But you will use PCS platform if you need protection against power failure with heavy motor, or you need protection against power dip, sag, or swell through ABC40. And then PCS if you have industrial loads like motors, compressors, and sensitive equipment. To give you an idea when to use the system is that it is advantage for PCS over the UPS if you have a system that is 600 kVA above. Okay, but if you have a 600 kVA below, and there is, if you see that a power failure is not a problem in your system, then it is also advisable to use this platform. Okay, why? Because you will not suffer of replacing the battery. Okay, and also the PCS 100 is protection against space and vector fault. So the advantage of this one for the commercial building is that if you have a commercial building that have a heavy ACU load or a cooling tower that is big enough, and then because of the power fluctuation or voltage dips and sags that is happening in that area, then PCS ABC system or PCS platform can actually help you with it. And with the PCS platform that you have, this can actually prolong the life of your component. All right. So for PCS 100 ABC product, we are actually we are actually present, or let's say we are used in this industry. Okay, with heavy industry, as you can see in automation, okay, automotive industry, F&B industry, pharmaceutical, medical, and semicon industry. So this is when you need to use the active voltage conditioner or UPSI. All right. So for just a information, so we already have a installed base. Okay. So we have installed base in 3 different semicon industry. The location is Industrial Park in Laguna. And the problem there is that the voltage sag are inherent in the system. Okay? It reduces the component lifetime. And also, this voltage sag affect their process. So if you see a semicon industry, what they earn in an hour is very precious. So in order to correct this one, they put a PCS 100 ABC40. So in these 3 customer, there are 7 installed base that reach more than 3 MVA of system. Just to give you an idea, how long was the first installation? We installed the first installation last 2012, and it is still running up to today. Okay, so Why ABC 40? Okay, so in the industrial part, there is no issue with power interruption. It's just that they need to mitigate on the voltage side as well. All right, and those dips that are lower, or let's say that dips that are corrected partially, these are commercially accepted by them. That's why they went to PCS 100 ABC 40, not UPSI. Okay, so uh, thank you so much, guys. And this is my last slide. And please let me know if you have some question. And this is the time. All right. Okay.
Thanks, Ace. So we'll let you catch your breath first. And I'd like to share some slides first to our audience so that, you can also anticipate the questions that they have shared while you were discussing your deck. So at this point, may I just share with the rest of the attendees the lineup of other sessions that we have for the month of April. So for on April 30, we'll be having a session to be conducted by Engineer um, Job by the fourth. So let me just share with you these slides. Okay. So it will be about low voltage selectivity. So this it's going to be at the same time, 2 o'clock to 2:45 p.m. And then on May 21st, we'll have a session on energy management solution to be conducted by Engineer Carla Bernal. And then on the 18th of June, we'll have a session on arc protection in medium voltage and low voltage system. Just to check, can everybody see the screen? Yes. Okay. So this session is also present in our ABB website. So this is the website address, and we have a table for the Q3 webinar sessions. And the registration link is already live. So if you want to pre-register or register early, you may do so, and do not be shy because we will be sending you reminders. Okay, and just to share with you, in case you're also wondering who are our channel partners in the Philippines, these are the channel partners for the electrification business of ABB here in the Philippines. It's also present in our website, so you may just click our website so you can have the full list there. And so now we go to the questions. Job, we have with us some members of the panel, the speakers for the upcoming sessions, and they will be helping out in fielding your questions to our resource person. And if there are some questions that you would like to ask still, just please feel free to share it with us. So, Job, can you read with to us the first question for Ace?
Hello. Actually, I see one question. One question from Julius Salaku. So, what is the reference of the typical annual power quality event? Is it the Philippine data? Yes, it is Philippine data. And actually, this data that we have from the Philippines is the same data that is also reflecting the data that we have from other countries, right? So it does not mean that we are living in a third world country, that other first world country is not experiencing this kind of power quality issue, but actually this power quality issue is pretty much the same, even with the first world country. All right. And the second question that I see here is that the issue within the harmonics. All right. So the harmonics problem, or the harmonics issue that we have, or I put it in the load side, it is because that typically the harmonics issues are being generated in the load side or from the end user side. And I understand that this harmonics problem is also in the distribution side, but I believe as of now that we already solved this system because of our transformer setup. All right. So I think this pretty much is not happening anymore in the grid side. So I just put the harmonics problem in the load side because it typically happens in the load side and it is generated from the load side. It's just that the grid is affected by harmonics coming from the load side. Depends on the transformer setup. All right. Any more question other than that? All right, I see one question that I'm sorry if there is. I think the slide is lagging behind the audio. I'm not sure about
the
this.
question is,
Yep.
there's a question, what is your solution for single phasing?
All right, the solution for the single phasing is the PCS portfolio because it doesn't just save the solve the issue of power quality, but it's also solve the single phasing issue. Regardless of, it depends on how big is the load.
Okay. What type of batteries you use for UPS1?
All right. So for the UPS, it's a UPSI. UPSI because it is a UPS industrial type. So this is a true industrial UPS because when you say industrial UPS, this is a 1:1 conversion. Okay. So the battery can be VRLA, lithium acid, or it could be lithium. All right. It depends. And the battery, we have a stringent, let's say, checklist if the battery will be supplied by the owner. So we also want that the battery is owner supplied since ABB does not have any battery. Okay.
So are there any more questions from the audience? Can you check the chat box?
All right. Okay.
Is the design
There's another question here. It says,
Go ahead, Job. Sorry.
yeah, the question here it says,
Hi, Job. I cannot hear you. Is it coming from Mr. Doming Abella? Is this the question of up to what spectrum is your active filter working at? Well, for our harmonics filter, this is actually working up to 100, 100, up to the 100 harmonics. We can have that. But usually, if you have a harmonics solution, or we have harmonic solution, we adjust it to the 7th and 21st harmonics, and then all of the others harmonics are solved. Okay.
Let's entertain one more question. Last question.
You're welcome, Mr. Domen. Okay. All right. So
hello? Yeah, there's another question here. Hello?
yes.
Go
Yeah.
ahead, Job.
Yeah. If the design of a particular mall or office is ongoing, can consultants include this equipment in their design? If yes, is there any rule of thumb in sizing the equipment?
All right. Okay, that is a very good question, Job. All right. So first of all, if we were gonna put this product in a mall or any commercial establishment, first we need to have the power quality PQA analysis. Okay. because in this way we will know which type of solution that we will need to put into the system. Okay, so if it depends on the single line, usually what we want is that the loads that the end user wanted to protect, okay, in a certain branches, we want to put the PCS component on its main bus. So if we put the PCS component in the main bus and in series on the main bus, it means that it will correct all the components that requires protection. Okay, does it answer your question, Job?
Well, actually, the question is, during the design phase. So basically, if I understand this correctly, sir, I don't think the PQA would be possible kasi design phase pa lang.
All right. So during the design phase, so we can actually have a PQA on what are the other installed base sets that in that area. Example, if we're gonna install it to a certain industrial park. So if it's in the design phase, we should already ask for a power quality analysis on the other area, because if we're gonna put if we're gonna put the PCS ABC 40 and then they require a 0% voltage protection, and then later on we don't want the customer that will go back to us by the PCS ABC 40 cannot correct it. But just to be safe, if we're gonna use the PCS ABC 40, we will have to have the PQA. But if we're gonna use the UPSI for this system, the rule of thumb is that whatever the load of that you wanted to be protected, so that is also the same power that will be used for the UPSI. Okay. Right.
Carlos, one of our engineers, Carlos Bautista, would like to add something to the discussion. Carlos, please unmute yourself. You're recognized. Carlos, can you hear us? Okay, sige. Let's proceed to the next question. Let's just go back to you in a bit. So there was a request if the link for the webinars can be shared. Of course, we are flashing it right now. I hope you are seeing the screen. So this is the website of ABB Philippines, and there's a microsite for our webinars. So it's up for improvement still. We ask for indulgence because we are just starting, but the registration link is all of it are all live. So you may click each one and it will bring you immediately to the registration landing page. So if whichever webinar you choose, you just need to click this red button, which has a register item on it, and it will bring you to the register landing page for that specific webinar. So each link is attributed to one webinar. So there's no limit. If you want to attend all of our webinars, of course, we'd love to have everyone joining us always, everyone. And we'll also be mapping several campaigns. Just please continue to visit this website because we will be updating this with our upcoming online activities and online engagement. So, Carlos, are you there? Okay, can't unmute. Let me just do something. Okay, let me just do something for you.
Okay, guys.
Right. There's another question. This one's coming from Engineer Noel. He is asking if we are also offering power quality analysis.
We, as ABB itself, we do not offer the power quality analysis, but we have partners that can offer this to them. So our partners are factory certified for this kind of solution.
Okay, do we have more questions from the audience, or perhaps Carlos can give his input now?
Probably for yeah, Carlos, can you speak up now? Okay. So just to give the people idea, Carlos is our PCSC sales engineer, and if you have any problem or any pains or like in the design stage or any existing industry that you have and having problem with this power quality, please give us please send us an email, and also please do not forget to answer the the survey right after the webinar.
Okay, I don't think we'll be hearing from Carlos because apparently he's not attached to the audio. So anyways, we need to wrap this up. Thank you again to Ace and to all of the panelists that we have on board. Thank you to all of the attendees who registered for this webinar. We're looking forward to seeing you on April 30. So we're inviting you again to please register early and join us on the same day, Thursday. It's a Thursday at 2 p.m. for the webinar on low voltage selectivity to be delivered by engineer Job Mayo Dafor. So thank you so much again, and keep safe, everyone. We hope you had a good and learning session with us. We'd love to hear your feedback. So please don't forget to answer our quick survey we have prepared. Thank you, sir. Thank you for your immediate good feedback. We'd love to hear and read more from you. So it's part of our continuous improvement practice. So we'll ask for your help on this one. So thank you, everyone, and have a good day ahead. Thank you.